Betelgeuse, the iconic red supergiant perched on the shoulder of Orion, has captivated humanity for centuries. This massive star, easily visible to the naked eye, has recently exhibited unusual behavior that has ignited excitement and speculation among astronomers and stargazers worldwide. Known for its reddish hue and immense size, Betelgeuse has been a fixture in the night sky, yet its recent fluctuations suggest that this celestial giant is entering a new and dramatic phase of its existence. Situated approximately 650 light-years from Earth, Betelgeuse is a red supergiant star, which means it is nearing the final stages of its life. To grasp its enormity, imagine placing it at the center of our solar system. Its surface would extend beyond the orbit of Mars. Its immense size, combined with its relative proximity, makes it one of the most studied stars in the galaxy. Over time, astronomers have documented the star's brightness variations, a trait known as being a semi-regular variable star, but recent changes have been extraordinary. Between 2019 and 2020, Betelgeuse experienced a dramatic great dimming, where its light faded significantly. This unexpected drop in brightness triggered widespread attention, both in scientific communities and in popular media. Following this event, the star brightened again, shining even more intensely than usual. In some cases, it has been observed to increase in luminosity by more than 50%, and on May 20, 2023, the BetelBot's Twitter account, which tracks the star using data from the American Association of Variable Star Observers, reported a staggering 142% increase in brightness. As a result, Betelgeuse temporarily rose to become the 7th brightest star in the night sky, climbing from its usual 10th position. The star's current behavior has provided scientists with a rare opportunity to witness a massive star's final stages before a potential supernova. Astrophysicist Andrea Dupree, of the Harvard-Smithsonian Center for Astrophysics, explains that Betelgeuse's rapid luminosity fluctuations allow researchers to study stellar processes that were previously theoretical. By observing the star's outer layers expanding and contracting, astronomers can infer what happens in its core, where fusion of elements drives the star's life cycle. Inside Betelgeuse, extreme pressures and temperatures fuel a series of nuclear fusion reactions. Initially, helium fuses into carbon, then carbon into oxygen, followed by heavier elements such as silicon and iron. These reactions release energy that counteracts gravity, keeping the star stable for millions of years. Eventually, however, the core will exhaust its fuel. Without outward pressure to counterbalance gravitational collapse, the core will implode, potentially forming a neutron star or a black hole, while the outer layers explode outward in a supernova visible across the galaxy. While this might sound imminent, scientists stress that predicting exactly when Betelgeuse will explode remains impossible. Professor Peter Glover, an expert in supernovae at the University of Portsmouth, points out that although we understand the processes that lead to a star's death, no current method can determine the precise timing of such an explosion. In other words, while Betelgeuse is undeniably approaching the end of its life, this might occur tomorrow, or in tens of thousands of years. Betelgeuse's recent behavior, however, has challenged traditional understanding. Historically, its brightness cycles lasted about 400 days, but post-great dimming, its variability has accelerated to roughly every 130 days. These dramatic swings suggest significant changes in the star's outer atmosphere, possibly caused by massive ejections of gas and dust. Observing these phenomena provides valuable insight into the processes that precede supernovae, giving astronomers real-world data to refine their models of stellar evolution. Interestingly, Betelgeuse's variability is not a new discovery. Ancient civilizations, including Aboriginal Australians and the Greeks, documented its changes in brightness thousands of years ago. Their observations highlight the star's long-standing role as a guide and point of fascination for humanity. Today, modern telescopes and satellites, such as the Hubble Space Telescope, allow us to monitor these variations with unprecedented accuracy, revealing new layers of complexity in the star's behavior. The potential supernova of Betelgeuse is more than a scientific curiosity. It could become a spectacle visible even during the daytime. Astronomers predict that when it explodes, it could shine as brightly as the moon, possibly casting shadows on Earth during the night. Though we are far enough away to remain safe, the explosion would provide an unparalleled opportunity to study a supernova in detail. For amateur astronomers and enthusiasts alike, witnessing Betelgeuse's death would be a once-in-a-lifetime experience, illuminating the life cycle of the most massive stars in the universe. Beyond its immediate spectacle, Betelgeuse offers insight into broader cosmic processes. Massive stars like this contribute to the creation of heavy elements, seeding the universe with materials necessary for planets, life, and even human civilization. When Betelgeuse explodes, it will release elements such as iron, carbon, and silicon into space, which over millions of years can become part of new stars, planets, and potentially even life itself. In this way, observing Betelgeuse connects us not just to the star itself but to the ongoing evolution of the cosmos. Furthermore, Betelgeuse's behavior has implications for understanding red supergiant stars in general. By comparing its fluctuations with those of other massive stars, astronomers hope to predict the behavior of similar stars in distant galaxies. This research can also refine estimates of how often supernovae occur, a crucial factor in modeling the evolution of galaxies and the distribution of elements across the universe. Technology is advancing rapidly, enabling even more precise observations of Betelgeuse. Instruments like the James Webb Space Telescope and ground-based observatories are poised to monitor changes in the star's surface temperature, luminosity, and chemical composition. These observations could reveal previously unseen phenomena, such as stellar convection cells, massive currents of plasma that transport energy from the core to the surface, or even clues about magnetic fields that influence stellar evolution. As the universe continues to evolve, stars like Betelgeuse remind us of the impermanence of even the most massive celestial objects. They live fast, burn brightly, and end spectacularly, leaving behind remnants that fuel the next generation of stars and planets. This cycle of birth, evolution, and death is a central narrative of the cosmos, one that we are fortunate to witness in real time. For those in the southern hemisphere, Betelgeuse can be seen shining brilliantly at dusk, perched on Orion's shoulder. In the northern hemisphere, it becomes visible as the nights grow longer, allowing more people to observe this fascinating star. Its visibility, combined with its dramatic behavior, ensures that Betelgeuse remains one of the most studied and admired stars in the night sky. In conclusion, Betelgeuse represents a bridge between humanity's ancient fascination with the stars and modern scientific inquiry. Its fluctuations, accelerated since the Great Dimming of 2019, provide insight into stellar processes, supernova precursors, and the creation of elements essential to life. While the exact timing of its ultimate explosion remains unknown, observing its evolution offers a rare and profound connection to the universe. If you want to stay updated on the latest cosmic events, including Betelgeuse's ongoing story, be sure to subscribe to our channel, like this video, and turn on notifications. By following these developments, you join a global community of explorers, witnessing the universe reveal its secrets one luminous star at a time. The story of Betelgeuse is far from over, and the coming years promise discoveries that could reshape our understanding of stars, supernovae, and the cosmos itself.